Welcome back to Truck Tech. You know, we told you we were going to do more than one look at the new Volvo VNL, and we are. This week, we're going to spend some time with Dwayne Teagles. He is the product marketing manager for Powertrain at Volvo Trucks North America. And Dwayne has some interesting perspectives. He really does help us understand this on several levels, both sort of at the top level and then maybe down a little bit into the weeds. But you know, we call the show Truck Tech, so let's be technical. Have a look. Welcome back to Truck Tech, everyone. You know, this time we're going to talk a little bit about the Volvo Powertrain in the new VNL. The best person to explain that to us is Dwayne Teagles. Dwayne is the product manager for Powertrain at Volvo Trucks North America. Dwayne, thanks for being here.
Yeah, glad to have you.
All right, so here we go. Now, this gets a little bit, well, it's quite large, isn't it? But there's a lot to this, but I think one of the first things we want to understand about the powertrain change, the biggest powertrain change, the one you guys were talking most about, is 10% better fuel efficiency. About 80% of that, I think you said, is through aero, and maybe 20% is powertrain changes. Why don't you walk us through that a little bit?
Yeah, so it may seem a little strange, a powertrain guy talking about aerodynamics, okay? But they do have a cohesive relationship between one another. You know, the average truck going down the road takes about 325 horsepower to run it through some rolling hills, 8,000 pounds. That's about what it takes. So what we've done with the aerodynamic improvement is we've reduced the required horsepower. So we've taken that 325 at 55 miles an hour and we've sliced off 16 horsepower just based by the aerodynamic requirements. The change here is that out of that 325 horsepower required to pull that load over rolling hills, we are now able to do it with less, 16 horsepower less, and still do the same job. And what that means is less horses at the trough drinking means less fuel being consumed. So that's kind of the concept.
Now, if the trucker says, wait a minute, why are you taking away horsepower from me? I want more oomph. You're saying you'll feel the same.
Well, actually, you'll feel more because we're not taking away from horsepower. The engine is still the 455 horse or the new 500 horse that we have out there. Okay, what I'm saying is for the same road and terrain and load, because of the aerodynamics that we have, it requires now less horsepower. Those aerodynamic resistances require more horses to push them through. So we're allowing you to use those horses to pull a hill or pull a load more efficiently or more powerful.
Chris Stagler last month showed us that, and you know, when we looked at the overall truck itself, and we saw how sculpted it really is. We started to see that in Super Truck 2, of course, and
right.
There was some carryover there. So the work that they've done on the aero really does complement, I guess,
It does.
What you're doing. So maybe you can talk a little bit about what you've done with your 20% of this.
Yeah, so when you look at the aerodynamics side of it, now we're going to go affect the engine side of it a little bit. You know, we look at the 6-wave versus the 7-wave piston. The requirements of the horsepower needed for moving that truck now allows us to move into a more efficient piston design. So we went into a 7-wave piston. So we've pushed a flame or fuel down into those 7 little pockets of the piston. Previously, the 6-wave worked a little bit more efficiently with a little bit heavier load behind it, which was just pushing wind. So now that we've gotten rid of that wind, we've been able to move to a 7-wave piston, which gives us about 0.7% improvement in fuel economy just by the piston design alone.
7-wave, 6-wave. I think you just said, you have to describe that for the audience a little bit, what you mean.
Yeah, so if you look at the top of our piston, it has little indents all the way around it. Look like almost little pockets, indents, and there's 7 of them as you count all the way around there. And then on the 6-wave, there's 6 little indents there.
Okay, math works.
Yeah, and to complement that, the injector itself has little holes in the top, in the injector itself that focus the fuel right down into those pockets.
Okay, so there's one. That's one thing that you've done. You've got some other things. So we get to the transmission in a moment. Is there anything else on the engine itself that you want to point out?
Yeah, so there's some other changes that we've done. We've changed the geometry, the overall revolving geometry of the engine. We've reduced the height of the piston, and we've also extended the connecting rod length. What that does is change the angle of the piston and connecting rod and the pressure that it applies to the side of the cylinder. So it has less friction every time that piston goes up and down. So it's what we call sacrificial losses. So less friction, less loss, better fuel economy.
Right.
So that's kind of what we're doing with, again, the shorter piston and longer rod. The other thing that we've done with this is we've put in a variable displacement oil pump. Now that variable displacement oil pump, it's exactly what it is. It's a variable vane displacement oil pump. And what it does is changes its displacement slightly to give the engine the optimal amount of oil. No extra and just enough to do its job. Okay, so that means that that horsepower may be small, but it's going to the wheels or reduce the amount of fuel that's being consumed.
Let's take a look at, for just a minute, at the transmission. You talked about something that you've done here that's also increased the efficiency.
Yeah, so we've increased or decreased the shifting speed between gears with the transmission. So we've reduced that by 30%. So it shifts 30% faster than previously. So what does that do in retrospect? Well, every time you shift a gear, there's about a 27% split between each one of our gears. So the engine revs up and then it shifts a gear and the RPMs drop about 27%.
Okay.
Now that shifting speed, what it does is it adds time to that drop of RPMs. So maybe it's going to be a drop of 28 or 29%. So the quicker you can make that shift, the quicker that you'll be able to engage that gear and stay in the sweet spot of the engine. And that's ultimately what you're wanting to do, is keep that in that sweet spot of the engine so you're burning less fuel. Now it's done a couple different ways. We changed the throw on the clutch. So we've decreased it. It may seem very small, but little details make a difference. We've changed it from 4 millimeters to a 2 millimeter throw. Okay, so
You're saying fill, is that right? Or throw?
throw, sorry.
Throw, okay. So gears, the throw between the gears.
Yeah, so the clutch would actually throw, it used to throw 4 millimeters. This would push out 4 millimeters, and then now it's 2 millimeters. Okay, so the shorter distance reduces the time it takes to actually shift that gear. The other thing that we've done is we've put another clutch inside the countershaft brake. Okay, what that does is it allows that countershaft brake to slow quicker. Now, when we shift gears, we have to match the input shaft and the output shaft, or input shaft and the countershaft at the same speed. By doing that, by putting that additional clutch in there, it slows this down quicker, and by changing the throw on the clutch, we get quicker shifting. That's where we get that 30% quicker shifting.
Okay, I think you've said that a human probably can't shift as fast as this can.
No, they can't. I know we'll have some people that challenge us on that, but it's milliseconds. It really is how fast that, and you'll get the opportunity to enjoy that.
Is this going to feel more like a true automatic then when you're driving, because you're not going to sense the hesitation, if you will, between the shifts?
I don't think it'll be quite to the automatic. You will feel the shift, but it'll be very quick, extremely quick.
And that also contributes then to fuel saving.
It does.
And the correlation there is.
Well, there's two correlations. One's fuel savings, which result in dollars. The other one is better acceleration, which kind of ties not only into the transmission, but to other rear axle ratios that customers may not have thought about. So a pretty common rear axle ratio that we have today is a 247. Now customers may be a little hesitant to drop down a little bit harder. We have our I-Torque spec, which is a 215. So the shifting performance we're getting from the transmission, the faster shifting, actually in some cases will get to 215 without accelerating 247.
Wow. Okay, so let's talk for just a minute on a historical basis. I mean, the I-Torque and I shift, right? Would be
No, you're right there with it. Yep.
Okay, I-Torque and I shift.
Right.
Basically, you guys are pioneers in that space, really. I mean, we go back to 2007, right? Mm-hmm. To when AMTs were not 99% of the industry. They were
some had them and some didn't. We've seen some competitors go all the way up to 18 speeds now and put an AMT in, and you said you're done with manual transmissions.
Yeah, this year we will offer a manual transmission in our heavy haul application and also in our vocational applications. But for our long haul applications, our new VNL, we will not offer a manual transmission.
You know, we have talked about a number of things in the first episode that we did on the truck with Chris Stadler, and we talked a little bit about packaging.
Sure.
And there's a packaging aspect now to Powertrain as well. You want to take us through that?
Yeah, there is, and we've had packaging for some time. We've got a pretty extensive packaging offering, but we've kind of slimmed that down for a little easier understanding for our customers. We run 3 different packages that we have. One is what we call our Super Direct. That's available anywhere from a 405 horse 1750 all the way up to a 500 horse 1950 engine. Now, the
Those
reason
are torques, right? Engine.
yes, it's 1950 torque. Yep.
Yep.
Now, those are coupled with, when we say Super Direct, it's with a direct drive transmission. So only a direct drive transmission is Super Direct is, and it's a 12-speed transmission. Those are available in ratios from 1.95 to 247. So the optimal range where we're looking to set that, the best one I would say for an 80,000 pound range is our 215 in the Super Direct. And that's kind of set up again for 80,000 pounds, but a speed limit of roughly about 68 miles an hour. And that's where most of our customers typically run, is at 68 miles an hour. So that's our first package. The next package I would consider would be our iTorque spec. This is our most fuel efficient and versatile spec. Again, we have an 80,000 pound application, and then we're rolling out a new one that ranges from 103 to 110 for our iTorque spec. Now, those do require a 13-speed transmission because we need a little bit more startability. So at 13 speed has a deeper gear in the first gear. Every other gear is the same as a 12-speed. Now, our 80,000 pound applications will be a 215 to a 217 rear axle ratio. So that gets you a downsped application, 70 miles an hour. This thing's cruising at 1,000 RPMs. Now, if you're looking more into like a Canadian market where they're typically running, over 100,000 pounds, 103 to 110, then we have our iTorque that runs a 247 and a 264. So it has the opportunity to spend some time in direct drive. Nothing wrong with that. It's designed to do that. Direct drive's a great efficient gear. That would be one down from the top gear, and then when it's lightly loaded or running on flat terrain, it'll spend time in overdrive and the engine RPMs will drop down.
When you mention Canada, I'm thinking of forestry, I'm thinking of things like that,
Sure.
heavier haul.
Yep.
Stuff, right?
Yeah, Canada's typically a little bit heavier application. They run heavier loads up there. B trains running across from coast to coast. So a lot of big stops.
B train, I'm sorry.
Yeah, B train. So they'll typically have 2 trailers behind the truck.
Okay, gotcha.
2 53-foot trailers. And then the last one that we have is our straight torque application. Now, this is for those that are a little bit more performance orientated. That would be a rear axle ratio from a 247 up to a 342. Now, those are applications available anywhere from 80,000 to 143,000 pounds. So our turbo compounded engine you see behind you is quite capable of pulling any load that you have out there. And again, those are available in the higher horsepower ranges from anywhere from 405 all the way up to 500. And the 500 is available in a 1950 torque. So 3 different options: Super Direct, iTorque, and then our straight torque.
And basically the customers know, or the fleet buyers know what their needs are, and you can sort of point them to one of the 3 and say, this is probably your best bet?
Yeah, so again, we'll look at it kind of like on speed and weight. How fast are you going? Here's your speed. If you're doing below 68 miles an hour, the direct drive, Super Direct is probably going to be your best. If you want to go a little bit faster and you want to be efficient in all kind of markets above 65 miles an hour, that's your iTorque spec. If again performance is a little bit more your game, then you have the straight torque there, and that gives you full power all the time.
Would your performance people basically be the ones who would have been the last to convert from manuals?
Well, I don't want to make any assumptions, but There is a higher level of performance there, and sometimes that's more important to a customer than fuel efficiency. Maybe they're pulling a heavier load for some reason, or maybe they're in a heavier grade that they need that extra power or a little bit more gear to that. So,
And that would also be your vocational truck, pretty much, is that right?
well, right now we're introducing the VNL, which is typically not a vocational
highway truck, okay,
So,
yep.
so it'd be a highway truck. But we do have some that are spending significant time in the Rocky Mountains that may, hey, I want a little bit more performance, or, they're just normally pulling a little bit more of a load, so they need or want that.
I want to talk for just a minute. I love the acronym EATS, because it's, the exotic treatment, because it, eats things. But really, when we talk about that, you've now, from a serviceability standpoint, are addressing this in a different way. You want to walk through that?
Yeah, so we have our current one-box system that we can go ahead and remove the diesel particulate filter in it. Or pull the whole system down. But one of the nice things that we've moved to is a linear exhaust after treatment system, EATS. And that allows us an advantage in serviceability. So it's broken into 3 different sections. It's linear in fashion, round in shape. And it has band clamps on it on each section. So it's 3 different sections. The first section is the diesel oxidizing catalyst. Then you have your diesel particulate filter, and then you have a mixing chamber, and then last but not least, selective catalytic reduction. Okay, those components, before, again, you weren't able to service all of them without replacing the entire box. The diesel particulate filter you could, but now we can replace each component if the diesel oxidizing catalyst goes bad or the diesel particulate filter goes bad. You can service those individual components on an individual basis, so it should reduce the cost of operation.
Are those the kinds of things that can be found through predictive maintenance? Are they kind of aligned with a predictive sort of, I might be having an issue here, or?
Well, we're always monitoring the after treatment system, so we'll alerts on the dash. So if there are issues that are coming up, the driver is always is first alerted. Yes.
Yeah. So I think that I just want to sort of spend a moment here on history, because you've got a great history around transmissions. I mean, if we think about iShift 2007, it was among the first to sort of usher in the era of the automated manual transmission, right? History?
Yeah, the transmission, I think it's brought in some greater efficiencies. The advantage of the iShift transmission is it does shift faster than a manual transmission. That's allowed us to drive some pretty fast ratios. So you may have had some challenges driving those ratios. If you drive down to, let's say, a 2:15 ratio, going down the road, it has what we call a gradability. Means it will climb a grade before it'll do a downshift. So with a 215, it'll actually climb about 7 feet, and then it does a downshift. So the advantage of an iShift transmission is its ability to shift quickly, and that the driver doesn't have to shift that either. When you look at a rear axle ratio of, say, like a 308, which is pretty common in a manual transmission, a lot of our customers like that. It has a gradability of 1.5%. Now, what does that mean? Gradability is like some crazy science term, right? So let's bring this down. That means that truck will go up 15 feet in elevation, and the driver will have to do a downshift to maintain that grade. So what happens now is we're trying to do down speeding with the iShift transmission. So it shifts quicker. So that transmission now, we're able to drive a 215 ratio, which has a gradability of 0.7, which is about 7 feet. So now that truck goes up 7 feet and the transmission does a downshift. Goes up 7 feet.
And you're saving fuel doing this, right?
Right. But if you use those ratios today with a manual transmission, that driver would always be downshifting all the time. Every time you come to a grade, you'd have to downshift. And he'd be so tired at the end of the day. So that's the advantage of the I-Shift, is it does that at those lower grades and allows us to use faster ratios that we would have never been able to do with a manual transmission before. So that drives ultimate efficiency. There's a huge difference between driving a super fast ratio like a 215 versus a 308. So those really give big financial gains to the customer.
You know, one of the things that I think is interesting, Dwayne, is that, you know, and you guys brought it up really, and that is this idea that, you know, creating kind of an equivalency between electric trucks, which you have promoted heavily, and you talk about them a lot at all the way at the parent level, the corporate level. There was always numbers shared and things like that. There's an interesting number here that you shared, which is that if you just take the North American truck sales, roughly 30,000 truck sales, and you apply a 10% fuel savings or fuel efficiency to it, that would basically be the equivalent of 3,000 electric trucks. Do I have that right?
You know, you have it right. It's just basic math. You know, for every gallon of fuel burned, you know, it's 22.4 pounds of CO2. So a 10% return or 10% reduction in fuel burned, it directly correlates to those of an electric vehicle.
And what's interesting about that is that we're still in the very early days of electric vehicles. There's no question about that. And, you know, we talked to Chris a little bit about the idea that, you know, as you look at the VNL today, that's not really a good candidate for an electric truck because there's no infrastructure for it, and there's arguably no battery density good enough to be charging. Now, that may happen someday. We're not there yet. But this idea that we will be running diesel trucks for decades longer is the truth. And you're now sort of saying, here it is on one hand, and here it is compared to another. And I think it's interesting because I haven't seen anyone do that yet.
Yeah, you know, there's a place for electric vehicles, and they have a great range in their application. You know, a regional haul truck, they work fine. You know, to your point, I think we'll continue to use diesel engines for some time yet. And the opportunity that Volvo has right now is to try to reduce that carbon footprint by putting out more fuel efficient products. Not only does it help, you know, the end customer as far as dollars, but it also helps out the environment as well. We're reducing CO2 just by reducing the amount of fuel we burn.
We have regulations coming, actually sort of stalled a little bit at the CARB level this year with the Advanced Clean Fleets rule, but it's not going away, and we know that. We also have EPA in 2027 or thereabouts. This new engine, reworked engine, is basically ready. You've got some tweaks, I think you indicated?
Yeah, I think we'll continue to use the D13 platform as we move forward. There'll be tweaks in, you know, the after treatment system and the turbos, but the main frame that you see behind you here, we'll continue to use here for the foreseeable future.
Great. Thanks very much. Appreciate it, Dwayne.
Thank you.
Dwayne Teagles knows his stuff, and you can tell just from the way he's able to explain some of these powertrain developments in the new Volvo VNL. Really great to spend some time with him. We hope you enjoyed it, and we'll see you next time.